Hey everyone! Welcome back to our series. My name is Taddy and this is Jahadat.
And in today's episode, we're going to be covering a
Substitution reaction
with benzene plus a halogen.
So let's get into it.
Alright, now let's get started. First, Jahadat, what even is a substitution reaction?
Well, Taddy, that's a great question. A substitution reaction is when a group on the paired chain is swapped by another group, or substituted.
You're absolutely right, Jahadat. There are many examples of substitution reactions, but today we're going to be focusing on the reaction between benzene and a halogen, specifically chlorine.
Awesome. So to start us off, let's write out our general word equation. This is going to be benzene plus a halogen on the reactant side. Then we draw an arrow over to the product side. Any catalysts are written above or below the arrow. In this case, the catalysts of the reaction are either iron bromide FeBr or aluminum chloride AlCl3. Lastly, the products for this reaction is halobenzene plus hydrogen halide.
Great! Now let's write our actual word equation for the reaction. On the reactant side, it will be a benzene plus a chlorine. Then we draw an arrow over and write the catalyst of AlCl3 on top of the arrow. Finally, the products are going to be chlorobenzene and a hydrogen chloride.
That's weird.
What is Jahadat?
Well, why don't we use iron bromide instead of aluminum chloride?
Great question, Jahadat. We use aluminum chloride because the halogen we've chosen is a chlorine. If we chose to use bromine, then we could use the iron bromide. Although there is also iodine and fluorine to pick from as our halogens, those reactions are not applicable. A reaction with fluorine and benzene is highly exothermic, making it explosive. A reaction with iodine and benzene is generally endothermic. Therefore, a reaction is often not possible.
Oh, great. Now I understand. Let's move on to drawing the structure diagrams for the entire reaction. To start us off, we're going to draw in our benzene. Benzene consists of 6 carbons, 6 hydrogens, which are insignificant for now, and 3 double bonds. But within benzene, all the electrons are evenly distributed due to a process called delocalization and shared evenly among all the carbon atoms.
Next, let's draw in our chlorine. Since chlorine is a diatomic element, we can't only just draw one single chlorine atom. Instead, we need to draw 2 of them attached together by a bond. Now let's draw our arrow over with our catalyst AlCl3 on top. Finally, it's time to demonstrate how we achieve our end products.
Using a red pen, we're going to show how the substitution process works with benzene and chlorine. First, we're going to make one of the insignificant hydrogens on the outside of the benzene significant by drawing in the H. Next, we're going to draw a dotted line over the line that connects the benzene to the significant hydrogen to indicate the breaking of bonds.
Now we look over to the chlorine and draw a dotted line here between the line that connects chlorines to indicate the breakage of bonds as well. Then, after the bonds are broken, these molecules are ready to form new bonds. As this is a substitution reaction, the hydrogen removed from the benzene will swap positions with one of the chlorines and make a bond with the other chlorine. On the other hand, the chlorine will swap positions with that hydrogen and connect to the benzene. We are indicating this swap by drawing a double-ended arrow between the atoms that are moving. Now that we've seen how the substitution reaction works, let's draw out our final products.
To begin, let's draw our halobenzene first. We will draw our benzene, then as we saw on the reactant side, chlorine replaces one of the hydrogens that was attached to the benzene. We'll place the chlorine in the same place that the hydrogen was. Now we'll draw a little plus sign, and to finish off our reaction, we know that the hydrogen from the benzene paired up with the second chlorine, so all we need to do is draw hydrogen-chlorine.
And that is the full structural diagram for a substitution reaction between benzene and one halogen, aka chlorine.
Wait, Taddy, you said one halogen, right? What would happen if we added another halogen? Like another chlorine, for example.
Oh, that wouldn't be too hard. First, you need to know that for benzenes with 2 groups, there are 3 common formations: ortho, meta, and para. An easy way I like to remember is using the abbreviation OMP. Ortho is used when the groups are attached to the first and second carbon. Meta is used when they're attached to the first and third carbon. And lastly, para is used when they're attached to the first and fourth carbon.
Oh yeah, isn't meta supposed to be the most stable formation for a benzene? I heard that in Miss Mo's class.
That's right, Jahadad. Now I'm sure you can figure out yourself what the reaction could look like. Let's start with writing the word equation.
Okay, so first we have our benzene, and that doesn't change, but this time instead of having just one halogen, we have two. So we're going to write plus 2 chlorine. Now we'll draw an arrow over and write AlCl3 as our catalyst above.
Perfect. Now let's draw out the structural reaction. Same process as before, we draw out our benzene, except this time instead of making only one hydrogen significant, we're going to make 2 significant, specifically the first and third one on our benzene. Now let's redraw our chlorines. Since last time we drew 2 chlorines, as chlorine is a diatomic, this time we're going to double that and draw 4, both pairs being bonded together. Now arrow over with the catalyst AlCl3 on the top, and let's draw our products.
To show the process, first we're going to draw a dotted line between each of the hydrogens and the benzene, and 2 more dotted lines over each bond of the chlorine. The hydrogens will both swap with 1 chlorine and will pair up with 1 chlorine each, and the remaining chlorines will take their spots on the benzene in the same meta orientation. This is displayed by drawing in a double-ended arrow between the groups that are being swapped. Now let's draw in our products. On the right side of the equation, we'll draw our benzene and 2 chlorines, one on carbon number 1 and one on carbon number 3. In addition, we'll be left with 2 hydrogen chlorides.
Now to finish off our word equation, our products should be a meta or M in brackets dash dichlorobenzene plus a 2 hydrogen chloride.
Hey Taddy, if 2 halogens are possible, why can't we do 3?
3? That might be too much.
Hey, I think we can do it. Let's start. So first, the word equation will be similar to the other 2 we already have done. Let's start off with our benzene first, and this time instead of 2 chlorine, we're gonna have 3 chlorine.
Oh my god, you're right. I think you're onto something. Then we draw an arrow over and write our catalyst above, which is aluminum chloride, of course. Now, to find our products, we need to draw it all out. Let's start with our structural diagrams again. First, we draw our benzene. Now, since we are going to work with 3 chlorines, we need to make 3 hydrogens significant. We're going to choose the insignificant hydrogens on carbons 1, 3, and 5. That way, no matter which way we choose to number our benzene, if we just have a look at 2 out of the 3 carbons that hold the chlorines, they will always be in a stable meta formation.
Next, we draw out our chlorines. Now we know the last time we drew 2 pairs of chlorines, this time we draw 3. Arrow over with the catalyst labeled on the top. Now we need to find our products. For the process, we draw 3 dotted lines in red between each significant hydrogen and the benzene. Next, we draw another 3 dotted lines between each pair of chlorine to cut off their bonds. The hydrogens will pair up with 1 chlorine each, and the remaining chlorines will once again replace the hydrogens on the benzene.
To draw out our products, we have a benzene with 3 chlorines on carbons 1, 3, and 5, plus 3 hydrogen chlorides. Now to fill in the product side of our word equation, we are going to end up with a 1, 3, 5 dash trichlorobenzene plus 3 hydrogen chloride.
Wow, I can't believe that's possible.
I know, right?
Alright, everybody. Thank you for watching.
Make sure you guys smash that subscribe button and turn on that notification bell so you never miss out on any of our videos.
And make sure to leave a comment down below on what you, our loyal subscribers, want to see next on this channel. See you next time.